You know that feeling, right? You turn on the tap, crystal clear water flows out. You flush a toilet and everything just disappears. It's something we rely on every day without really thinking about it. But behind those simple actions, there's this incredibly complex, constantly working system, often hidden from view. Today, we're going to pull back the curtain on that system. We're diving into a really fascinating area that, well, it literally keeps our water systems flowing. Asset management in the water and wastewater industry. Our insights for this deep dive, they come straight from notes we looked at from WaterJam 2025. We really zeroed in on how utilities manage their absolutely critical infrastructure. So our mission here is to understand not just, what asset management is, but how a real-world example, Prince William County, tackles this huge challenge of keeping complex facilities running smoothly. They blend high-tech analytics with invaluable human expertise. And you, our listener, you'll walk away understanding the nuts and bolts of how these crucial decisions get made to ensure the reliable service we all just expect.
Yeah, and what's really fascinating here is that, okay, it might sound super technical, but at its core, it's really about ensuring the reliability and sustainability of services that, well, every single one of us relies on every day. And this brings up a big question, right? How do these organizations prioritize spending millions, sometimes billions of dollars to keep our essential infrastructure robust, resilient, especially when you're dealing with assets that are so vital, but, often totally out of sight? That's the puzzle we're digging into.
Okay, let's unpack that. Asset management in the water world. When we talk about a systematic approach, what does that really mean here?
Exactly. It's systematic in that it's a deliberate process. It's about operating, maintaining, upgrading, and eventually even disposing of utility assets in the most cost-effective way possible. The ultimate goal, and this is key, is delivering reliable service to customers. While minimizing risk and maximizing the life of that infrastructure, it's about thinking ahead, not just reacting when something breaks.
Right, being proactive. So this strategic approach, it sounds comprehensive.
Right.
What are the key pieces that make it actually work on the ground?
Well, it's definitely multifaceted. You're looking at several key elements, sort of the foundation. First, inventory. Knowing exactly what you own, where it is, and crucially, its condition. You just can't manage what you don't know you have.
Makes sense.
Then, levels of service. Defining how reliable, how effective you need those assets to be for your customers. What's the target? Third, criticality. Understanding which assets are most important, which failure would hurt the most, be most costly.
Okay.
Then there's life cycle costing. Planning for all the costs, maintenance, repairs, replacement, thinking about the cost benefit over the asset's entire life. And finally, risk management. This is huge. Balancing the probability, the likelihood of an asset failing against the potential consequences if it does fail.
Okay, so it really is about that long-term view, that proactive planning, not just putting out fires. Now, inside this asset world, our sources highlighted a really key difference: linear versus vertical assets. This seems pretty fundamental to how utilities organize things. Can you break down that difference for us?
Absolutely. And this distinction, it's not just jargon. It really dictates different management strategies, different tools, different resources. So let's start with linear assets. Think infrastructure that stretches out, often underground. These are your classic miles of pipe in the ground.
Okay, like mains and sewers.
Exactly. Water mains, distribution pipes, sewer collection pipes, hydrants, valves, that sort of thing. There are tons of them. They're often buried, which makes assessing their condition tricky, right? And a failure, like a big main break, can impact whole neighborhoods. So managing these miles of pipe, it has its challenges, but it was, for many utilities, kind of a more uniform place to start building their asset management programs.
Okay, so that's linear. What about vertical?
Vertical assets. Now, these are the hubs, the nerve centers. We're talking water treatment plants, wastewater treatment plants, pump stations, storage tanks elevated or on-the-ground wells, lift stations, and all the complex stuff inside them. The big pumps, the electrical systems, the control systems, SCADA systems, for example.
Right, the buildings themselves too.
Yes, the buildings, HVAC, everything at a specific site. These are typically fewer in number than the pipes, but way more complex, intricate. They need specialized maintenance, close monitoring. And here's the kicker. Unlike pipes, which might be similar for miles, pretty much no two vertical assets are exactly alike.
Okay.
And that's the core insight. You can't really manage a vast pipe network using the exact same methods you use for a, say, multi-million-dollar treatment plant with all its unique equipment.
That's a really helpful way to visualize it. Pipes are linear, stretching out, plants are vertical, complex sites. Got it. Okay, we've got the theory down. But how does this actually work in practice? Let's take a trip, metaphorically speaking, to Prince William County, Virginia. They're not just doing asset management. They seem to be really pioneering an adaptive strategy, serving around 400,000 people, managing about 15 water storage tanks, and maybe 100 water and sewer facilities. Tell us about their approach, their blueprint.
Yeah, Prince William County is doing some really interesting work. Their asset management department, it's relatively new, but it's growing fast. A lot of that growth is driven by new automation and analytics they're bringing in. Now, while they did start, like many, focusing on linear assets, they've now formalized this advanced, data-driven approach into a bigger program they call the Asset Water Analytics Program, or AMA. And this AMA program strategically manages all their critical infrastructure, but it has these specialized ways of looking at the complex vertical assets.
Okay, AMA program. And central to that, you mentioned, is a risk-based scoring system. How does risk fit in, and how do they make their scoring system, useful?
Yes, risk is absolutely fundamental. Their core formula, the one they use to evaluate assets, is basically risk equals probability of failure multiplied by consequence of failure. Pretty standard, but powerful.
Okay.
But the key is how they use it, the scores they generate. They're designed very carefully to be defensible. They can back them up. Repeatable, they get consistent results. Objective, based on data, not just gut feeling. And crucially, data-driven. This rigor, this approach, it builds a lot of confidence for the decision makers, the people holding the purse strings. When they need to prioritize which maintenance project goes first, or which rehab, or even which asset needs full replacement, this objective ranking really boosts the credibility of the recommendations.
Right, to take some of the guesswork out. Our sources also mentioned the snowball effect of improvement there.
Yep.
That's a cool image.
How does their system actually get better over time? Yeah, it's a great way to put it. Because the department is relatively new, they're constantly refining things. Each year, they add more processes, they integrate more data streams into the system, and that directly improves their automation. It enhances the quality of their condition data, which is vital, and it deepens their understanding, their performance insights. So every iteration, every time they go through the cycle, it increases accuracy, it increases credibility, it creates this growing, more impactful system, just like a snowball rolling downhill, right? Gathering mass, gathering momentum. It's really an ongoing journey for them, not a fixed destination.
That makes sense. And this leads to something really crucial that was mentioned. Balancing all that data, all those numbers, with the knowledge from people in the field. How does Prince William County manage that? Because it feels like it would be easy for the data to just take over.
That's a really important point, and it raises a critical question. How do you make sure the data doesn't steamroll the real-world hands-on experience? Prince William County's philosophy is that the analytics are a powerful tool, definitely, but they're not the end-all be-all.
Okay.
They absolutely recognize that the field staff, the operators, the maintenance crews, these folks have invaluable firsthand knowledge. They know how assets actually behave day to day, what their quirks are. So the analytics, they're meant to reinforce and complement those observations, not replace them. It's about building trust between the data-driven planning side and the real-world operations side. This blend, this respect for both quantitative data and qualitative human expertise, that's absolutely key to their program strength. And honestly, it's acceptance and long-term success. Because without that buy-in, even the smartest analytics can just sit on a shelf, right? Or worse, get actively ignored if people don't trust them.
That balance sounds critical. Okay, so it sounds like a robust program now, but you mentioned they didn't just jump into the deep end with these complex vertical assets from day one. Tell us about that journey. How did they implement this? Starting with pipes, then moving to plants.
No, they didn't jump straight in, and that's pretty typical, actually. It's a natural progression for a lot of utilities. They began their asset management journey, like many, with linear assets, mostly the pipes.
Why start there? Is it just easier?
In some ways, yes. It's often the logical starting point because linear assets tend to be more similar in type. Miles of water mains, miles of sewer lines. That relative uniformity makes them a bit easier to categorize and model for that initial risk analysis. You could look at factors like pipe age, material, maybe braid history, soil conditions, and apply those factors across large parts of the network. This allowed for pretty effective automation and using GIS, geographic information systems, for prioritization early on. It helped them get a foundational understanding of their biggest pipe-related risks.
Okay, so once they got a good handle on those miles of pipe, then they shifted focus to the facilities and equipment.
Exactly. Once the processes for linear assets were established, running smoothly and actually producing useful results, they expanded their efforts. They started tackling the vertical assets, pump stations, tanks, treatment facilities. But like we said, these are a totally different beast. Fewer of them, sure, but way more complex. You've got all these diverse components inside pumps running differently, intricate electrical systems, control systems like SCADA and PLCs, programmable logic controllers, basically the small computers that automate industrial processes, like controlling pumps or valves in a treatment plant.
Gotcha.
And you've got significant structural components, too. So unlike the pipes, where one section might be much like the next, no two vertical assets are identical. That makes the analytics much more nuanced, much more challenging to apply in a blanket way.
Wow. Yeah, that sounds like a huge challenge.
Yeah.
Managing all that variety, that complexity. How did they actually manage to tackle that effectively? What tools did they use?
Right. It's a big step up in complexity. And this is where leveraging GIS applications and visualization tools became absolutely vital, especially for the vertical asset management piece. These tools allowed their staff to basically map out the facilities and their key internal components visually. They could display condition scores, risk levels directly on the map or in dashboards.
Ah, so you could see it spatially.
Exactly. And that visual context is incredibly valuable for vertical assets. It really helps translate complex technical data into something more intuitive. It makes it easier for both the field staff, who know the facility intimately, and for the decision makers who might need a higher level view to understand where the critical risks are located. It makes complex data actionable.
Okay, so this whole thing, it's not like a project they finish and then they're done, is it?
Mm-hmm.
You mentioned it's a continuous cycle. Tell us about that EMA program cycle. That sounds like the engine that keeps this whole improvement process going.
You're absolutely right. It's not a one-off. It's a dynamic, continuous improvement loop. That's fundamental to how it works. And it has 5 key steps that interconnect and, importantly, repeat every year.
Okay. What are they?
First is stakeholder engagement. And this is broad: engineers, planners, operators, maintenance crews, leadership, even regulators, and indirectly, customers. The goal here is to identify priorities, what matters most: reliability, safety, cost. It's also about building buy-in, making sure the data actually gets used to drive decisions, and, critically, ensuring alignment between that invaluable field knowledge we talked about and the data models. Without solid engagement, analytics can just become academic exercises, disconnected.
Right. Step 1, talk to everyone. What's next?
Step 2. Data availability. This is all about gathering the inputs: your asset inventories, your real-time scatter readings, condition assessments, maintenance logs, failure history, GIS data, everything. Challenges. Often data gaps, or maybe data isn't standardized across different facilities, which makes comparison hard. The goal is just to get enough quality data to support meaningful analysis. Garbage in, garbage out, right.
Definitely. Okay, got the data, then what?
Step 3, analysis and results. This is where the number crunching happens. They do the risk scoring, that probability times consequence formula we discussed. They do performance benchmarking. They use models like reliability-centered maintenance. This is where they turn raw data into, hopefully, a clearer roadmap for action. The outputs are things like asset rankings by criticality, maybe visual heat maps or dashboards showing risk hotspots, and importantly, prioritize lists for capital planning, big replacement projects, and O&M, ongoing operations and maintenance.
Okay, so that's the core analysis. What's step 4?
Step 4 is results analysis. And this is crucial. It's stepping back and asking, does this make sense? Do the scores the models spat out actually reflect what the guys in the field are seeing? Where do the data trends line up with operator observations? And where do they conflict? Why? And maybe most importantly, are the recommendations practical? Can we actually do this with our current budget and staffing? This is where that stakeholder input from step 1 provides a vital feedback loop, kind of a sanity check on the data.
Right, reality check. And the last step?
Step 5 is simply, cycle repeats. Every single year, the whole program, steps 1 through 4, starts again. They feed in new data, maybe updated condition assessments, new failure information. They refine the models based on last year's results analysis. And this continuous loop is what drives improvement. It keeps refining accuracy, building credibility, and ultimately leading to better, more informed decisions over time. It's that snowball effect in action.
That continuous loop makes perfect sense for managing something so dynamic. Okay, now let's really get into the weeds a bit. How exactly do they do this analysis part? Our notes mention they start by identifying components within a facility.
Yeah, that's right. To manage something complex like, say, a wastewater lift station, you can't just give the whole station one score easily. So they break it down into its major functional components. Think generators, pumps, the wet well itself, maybe grinders if they have them, The electrical systems, the force main pipe leaving the station, the building structure, HVAC, even an other category for miscellaneous bits. This breakdown creates a standardized structure. It lets them compare different stations more consistently, even if the stations aren't identical. That's essential when you're managing a whole portfolio of these diverse assets.
Okay, break it down into pieces, and then these individual pieces of the components, they get scored.
Exactly. Each type of component, pumps, generators, etc., receives scores. These scores are based on various factors like its current assessed condition, its historical performance data, its age, and how critical it is to that specific station's operation. Then, these individual component scores, they get rolled up, aggregated to create a composite score for the entire lift station or facility.
And this is where the operators get involved again directly, right?
Yeah.
It's not just sensors and historical data.
Crucially, yes. It's not just about the numbers spitting out of a sensor or a database. The operators, the folks who work at these stations day in and day out, they don't just do the routine maintenance. They also complete annual assessments using a set of structured questions about the components. This is really important for two reasons. It ensures consistency in how assessments are done across different stations and by different people, and it directly blends that invaluable field insight, their hands-on knowledge, right into the data collection process itself. It powerfully reinforces that core idea. Analytics are there to complement real-world expertise, not override it.
Okay, that blend seems key. And the absolute core of that analytical method, the formula you mentioned, BRE equals low FF multiplied by COF. Can you break down what those letters mean again and really explain why this specific formula is so powerful for comparing, say, a pump versus an electrical panel? They seem so different.
Sure. So BRE stands for business risk exposure. It's a really common and foundational risk-based prioritization formula used widely in asset management, not just in water.
Okay, business risk exposure, BRE.
Then low FS is likelihood of failure. Pretty straightforward. How probable is it that this specific asset, this pump, this generator, will fail within a certain time frame? This is typically based on those factors we talked about: its age, its current condition score, its past performance or failure history, maybe environmental factors like corrosion.
Right, likelihood, low F.
And COF is consequence of failure. If it does fail, what happens? What's the impact? This could range from something minor, maybe an inconvenience requiring a quick fix, to something truly catastrophic, like a major service outage hitting thousands of customers, or maybe an environmental spill leading to fines, or serious safety issues.
Okay, likelihood times consequence.
Exactly. You multiply the loss score by the COF score, and that gives you a normalized risk score, the BRE. And this is why it's so incredibly powerful, because it allows you to compare very different types of assets on a common playing field using the language of risk. So take your example. A pump might have a relatively high likelihood of failure. Maybe it's old and needs frequent repairs, but if its consequence of failure is low, perhaps there's a redundant backup pump right next to it that kicks in automatically, and replacing it is easy. Its overall BRE score might not be that high. But compare that to, say, a critical electrical panel. Maybe its likelihood of failure is only moderate. It's not failing constantly. But if its consequence of failure is extremely high, maybe if it fails, the entire treatment plant shuts down, then its BRE score could be much, much higher than the unreliable but redundant pump.
That makes so much sense. It allows for a fair comparison of totally different things based on their combined probability and impact.
Precisely. And that is why it's so vital for these complex vertical assets, because they are so diverse. Like you said, a pump is vastly different from a generator or an HVAC unit or a control system. You can't easily compare their raw condition scores directly. BRE provides that common risk language. It allows decision makers to objectively rank priorities across their entire portfolio, regardless of the specific asset type. And this lets them focus their limited resources, their time, their money, their staff, precisely where the overall risk exposure is greatest for you, the customer. It ensures they're making the smartest investments to maintain reliable service.
Wow. Okay, so stepping back, what does this all really mean for us, for you listening? This deep dive into asset management using Prince William County as this fantastic, innovative example. It really highlights just how much thought, how much strategy goes into delivering that water, removing that wastewater reliably. It's this really complex, kind of fascinating blend of data, technology, and that absolutely invaluable human experience and knowledge all working together. It's amazing how often taking a really systematic approach like they've done can help tackle even the most complex problems.
Yeah, absolutely. And if we connect this back to the bigger picture, it really underscores the continuous adaptive nature of managing this critical infrastructure, especially in a world with constantly evolving demands, aging pipes and plants, and increasingly sophisticated technology becoming available. And maybe think about how this fusion of data and human insight, this snowball effect of continuous improvement they've got going, how that might apply elsewhere, maybe in other complex systems in your own world. Could be urban planning, could be resource allocation in a business, maybe even just optimizing your own personal projects or how you manage your own assets. The core principles seem pretty universal, right? Understand what you've got, assess the risk associated with it, and constantly refine your approach based on data and experience. It's really about building a more resilient future step by step.